tutorials, SP2B online classes for NCERT and 10th standard, mathematics and science. So in the last topic regarding light, we had discussed regarding the real images, virtual images, and regarding objects, how we have to consider with respect to light. So now, regarding when we come to the objects, so if the object is very small, it should be considered as a dot, like a pinhead or a particular star which is very far away from us. So those objects are considered to be point sized. So if a particular object is very big, like a tree, a human being, or a vehicle, right, such objects are considered to be called as the big objects, and those in light in physics, they are called as extended objects. The extended objects are represented by an arrow mark which is having an arrow mark in the upward direction. So that is the symbolic representation of extended objects. So when we come to the types of images, so here we have real images. So an image which can be caught on a screen are called as the real images. So how particularly real images can be formed is they formed in front of the mirror, because the light rays after reflection from the mirror pass through the image. Therefore, they can be caught on the screen. So they are always inverted, right? And coming to the virtual images, these images are always erect. They are formed behind the mirror, and these virtual images is an illusion. Yesterday I told you regarding this in the previous session. It's an illusion. They are unreal images. So it appears as though they are formed, but in reality those virtual images do not exist. So it's an 100% it's an illusion. So based on these basic concepts what we had learned in the previous class, today we will go with a very important concept, that is image formation on plane mirrors. Right? That's very important now. So before going into that, just I want to tell you certain things which you need to know before understanding the formation of images on plane mirrors. So one thing is that when light rays coming from a source of light fall on an object, it is going to reflect the light rays. The object is going to reflect the light rays. But those light rays will be very large in number. Very large number. I am standing here, many lights are falling on me. That is from the source of light. Light rays are falling on me, and these light rays are getting reflected. So how many light rays are there? That's infinite, in the sense you cannot consider all the light rays. So therefore, for the sake of drawing ray diagrams to detect or to estimate or to understand the nature and position of the images formed, and to simplify the ray diagrams, we are going to consider only two light rays. Now this is very important. By drawing the ray diagrams to analyze, to detect the position and size of the object, to simplify the ray diagrams, the light rays which are coming after reflection from a particular body, those light rays, among those light rays, only two light rays are considered. So this is the very important thing. The next thing is, the light rays which come and fall on my body, and after reflection what they go, they are called as real light rays. So these real light rays are always represented by straight lines which are having a certain thickness in that. They are straight lines. So, but the virtual light rays, they are always represented by, or they are always drawn by using dotted lines, because virtual light rays do not exist at all. Just they travel behind the mirror. The virtual light rays travel behind the mirror, so therefore they are written in the form of dotted lines, as we used to draw the normal while we were discussing the laws of reflection. So real light rays are drawn by using straight lines, that is having a certain thickness in that. But in case of the virtual light rays, we are going to represent those virtual light rays by drawing dotted lines. So these virtual light rays will be drawn behind the mirror, whereas the real light rays will be drawn in front of the mirror. So this is very important. So coming to this concept, we are going with the help of a media. I will tell you how these, you can easily see that how these real light rays will be and how the virtual light rays will be, right. So a number of light rays coming from the point source, that's a point source. Coming from the point source, they fall on the mirror. So this is the rough surface. So these light rays appear to meet at a point behind the mirror, so that they are called as virtual light rays. So these are the real light rays represented by lines which are having certain width. So after reflection, the light rays are going to get diverged. So these light rays are drawn backwards. These light rays are drawn backwards by using the dotted lines, and these dotted lines are going to meet at a particular point behind the mirror. So, so you can see here they are getting reflected, they are diverging. So these are that is the virtual light rays, these are the real light rays. Okay. So we'll go with the very important concept, that is formation of images by plane mirrors. So keep this in your mind. Okay. So formation of image by plane mirrors. So usually we have plane mirrors in our home. When you go to hotels, you can see plane mirrors. If you go for a salon, you can see plane mirrors. If you go to very big malls, you can see the plane mirrors there. So at the road end, to detect the vehicles which are coming in the side direction, to see them, we have plane mirrors. So there are many uses of plane mirrors which I am going to discuss at the end of this session. So let us see how an image is formed in a plane mirror using a point-sized object. Right. Now, let us consider a plane mirror, so which is silvered at the one side of the mirror is silvered and it is coated red, so that to preserve the silver coating of the mirror. So just imagine there is an object at here, a point-sized object. Let us call it as the point O. So this is the object, point-sized object. So here many light rays from the source of light, many light rays from source of light, many light rays are falling on this particular object, and those light rays are getting reflected and they are moving towards the mirror. So among them, let us consider only the two light rays, because I told you earlier to make the ray diagrams very simple and understandable by everybody, we'll consider only two light rays coming out of that. So one light ray, let us consider it is moving in this direction. Let us represent that by a light ray. So a light ray falls on the mirror. This is the point of incidence. When we draw a normal here, let us take it as point A. We draw a normal and this becomes the angle of incidence. Let us represent it by I1. Let us represent that angle by I1, because the angle between the incident light ray and the normal is called the angle of incidence, as you know, according to the law of reflection. So here the angle of incidence should be always equal to the angle of reflection. So here the light ray is going to get reflected and start traveling in this direction, because mirror is a very smooth, highly polished surface, because inside that there is a silver coating, so that it reflects all the light falling on it. So a light ray coming from the object falls on the mirror at the point of incidence, that is A, so it is going to get reflected. The angle between the incident light ray and the normal, I am going to represent that by I1. So according to the law of reflection, the angle of incidence will be equal to the angle of reflection. So let us take it as this as R1. So this is the angle of reflection. So this light ray travels in this direction. Okay, it goes further. Now let us consider another light ray coming from the same point source. So let us take it as ray OA. Okay, ray OB. We have named already A. Let us call it as point B. So point B is the point of incidence. So at this particular point, let us draw the normal to the dotted line. Let's draw the normal here. So the angle between the incident light ray and the normal, we will call it as I2 here. This is the angle of incidence. We will call it as I2. So after the light ray falls on the mirror, naturally the light ray is going to get reflected. So according to the law of reflection, the angle will be the same. That is, the angle of incidence should be equal to the angle of reflection. So this light ray is going to get reflected, and let us call it as angle R2. That is the angle of reflection. So here the reflection happens according to the law of reflection here. So you get law applies here, law applies here. That is the angle of incidence is equal to angle of reflection. 100% gets applied. And when you observe these two light rays which are coming after reflection, they are diverging. They are diverging in the sense they do not meet when extended. When these light rays are extended any further, when I further extend these light rays, then they will never meet each other. That means they are diverging light rays. So now let us imagine these two light rays enters into the eyes of a person. Let us imagine these two light rays enters into the eyes of a person here. Okay, let us imagine this. Just a schematic representation. So this is the eye of a person. So the light rays are entering into the eyes of a particular person. Now, the eye, what it sees is, it sees that light rays are coming from a point which is behind the mirror. So to analyze that, we will extend these light rays backwards. We will extend these light rays backwards. So these light rays, let us extend it. These light rays, again, they meet at a particular point behind the mirror. So this is the image. So for the eye, it appears as though these two light rays are coming from a point from here, which is behind the mirror. So therefore, as it appears as though light rays are coming from that point from behind the mirror, let us represent those light rays by dotted lines, which represent the virtual light rays. So these are the two virtual light rays and these are the two real light rays. So as we see, as the person sees from this particular point, this image, he sees that the image is here, somewhere which is behind the mirror. So therefore the object here, what it is in front of the mirror, he sees that the same object is at the same distance behind the mirror. So this is how a particular image is formed using plane mirror. So if you if you have our face here, we can see the image of our face at this particular point. So if we place any object here, the particular object will be here. So something like that. So this is how the image is formed on a plane mirror. So these light rays are virtual light rays, as it appears as though they are coming from a point which is behind the mirror, and this image I, what is formed here, is called as a virtual image. This is not a real image, it is a virtual image because we are in front of the mirror, we are standing in front of the mirror here. Here the image is formed behind the mirror. We cannot, through the mirror, we cannot keep a screen to catch that image on the screen. That's not possible. So therefore, the object appears to be behind the mirror. Actually, it's not there. It appears as though it is formed behind the mirror. Therefore, these type of images are called as virtual images. These virtual images, as I told you, as I discussed you in yesterday's class, they will be of the same size. They will be at the same distance as the object is in front of that is the object, the image will be at a distance from the mirror as the object is in front of the mirror. That's very important concept. If the distance between the object and the mirror is some 10 meters, then the image is also formed behind the mirror at a distance of 10 meters. So if what is the size of the object, it is there, the same size of the object you can get here. So the image is here, the same erect image of the particular object, that is object is here, the same size of the object can be seen here without any changes in that. So this is the formation of image by a plane mirror. So we will take the help of a multimedia. Let us see through ray diagrams, through an animation, how actually it happens. This is the object, this is the image. Bring it near the mirror, the image also comes near. Take it away, the image also goes away. See the virtual light rays. These are the real light rays after reflection from the object. After reflection, it is going to the eyes. This is how the things happen. Bring it near, the image also comes near. Take it away, the image also goes away. Okay. So our next concept after learning the formation of image on a plane mirror, let us get into another very important concept, that is lateral inversion. Lateral inversion. So it's a very important phenomenon that happens inside a mirror. So if imagine yourself standing in front of a big plane mirror, you can see yourself totally. The entire body parts of us can be seen in the image. So when you stand in front of the mirror and if you try to lift your right hand like this, inside the image of yours, what you see in the plane mirror, it rises its left hand. So if you raise your left hand in front of the mirror, then the image of yours inside the mirror rises its, that is, right hand. So if you bring your right hand in front of the image, then the image of yours in the mirror brings its left hand. If you start moving towards the mirror like this, when you come in front of the mirror, right, your image also comes forwards, and if you go back away from the mirror, the image of yours also go back. So that's the phenomenon what you might have observed in plane mirrors. So among these two concepts, the first concept we will take. So always the object and the image of the object in the mirror are always reversed sides. Sideways they are reversed. So this phenomenon of sideways reversing of an object and its image in the mirror is known as lateral inversion. This concept is called as lateral inversion. This is a very important concept. So once again I will tell you this. If you stand in front of the mirror, if you raise your right hand, your image lifts its left hand. If you raise your left hand, then the image inside the mirror raises its right hand. Right? So if you turn towards your right, then the image in the mirror turns towards the left. So these sideways reversing which happens in between the object and its image in the mirror is known as lateral inversion. Right. Let us go with an example of a multimedia here. So it's very nice. So you can see here, if you raise your, this is the object inside, and this is the mirror image. So when you lift your right hand, in the image you can see it is lifting its left hand. right? This is what we call lateral inversion. So and also you can see here he has put his right leg, that is left leg forwards. So in the image you can see the left leg is, that is okay, the left leg is forwards. So this is what we call lateral inversion, right? Okay. So next is the nature of image formed by plane mirror. The same thing happens, another very important concept. So this is the mirror, this is the object, and this is the image. Let's see what happens. So if the person moves towards the mirror 2 steps, the image also moves towards the mirror 2 steps. So if it goes backwards, the image also goes backwards inside the mirror. So this is the another very important property of images in plane mirrors. It's important. So this is the right hand of the person and this is the left hand of the image. So you can see the badge here. The badge put on the person's chest is towards the right, and in the image it is towards the left. So they are equidistant. So if the distance is x1, then the distance is also here. Inside the mirror it is x1 itself. x1 stands for some number. If it is 10 meters, then also this distance is 10 meters. Okay, nice. So I hope you understand the basic principle behind the formation of images on a plane mirror. So let us go with its properties, that is characteristics of images which are formed on plane mirrors. Right. So the images which are formed on a plane mirror, we have seen that it's a virtual image, so it cannot be caught on a screen. So some of the properties are listed over here. So it is virtual. So these images are formed behind the mirror, and these images cannot be caught on a screen. That's the important properties. So it's virtual, it is erect. If you stand in front of the mirror, your image is also, it looks exactly like you. That is erect. And same size of the object. As what is the size of yours is the same size of the object inside the mirror. The distance of object from the plane mirror is same as the distance of image from the plane mirror. So if you are standing 10 meters away from the mirror, then your image inside the mirror will be 10 meters, what you just saw in the particular multimedia. So one of the most important characteristics of the image is that it is laterally inverted. So that's the concept what I discussed just now, lateral inversion, sideways reversed. Sideways reversing between the object and the image of that object in the mirror is called lateral inversion. That's the definition. If it means if you raise your left hand, it would appear in the plane mirror that you have raised your right hand. So these are the properties of the image which are formed on a plane mirror. Right. Let us go with the uses. The uses, you know it. Many of the things, many types of mirrors we used we use in a daily class, that is life. They are used as looking glasses. That is in your glasses, looking glasses. Right? They are used in solar cookers. Solar cooker is a type of box made this thing which is covered by a mirror inside it, so that more and more light rays falling on it get entered into the solar cooker, so that more heat is produced and food is cooked very fast. So it is used in constructing periscopes, it is used in submarines. So you will be inside the water, and if you want to see what's happening outside, you can use this periscopes. So there mirrors are used. They are also used to make kaleidoscope, a toy which produces beautiful patterns. So usually when you were kids, we used to make kaleidoscopes. We take a usually box, we put mirrors inside it in all the sides, and put some broken bangles or something, colorful things inside it, and if you rotate that, we used to see beautiful patterns of that. So that's a kaleidoscope. They are also used in various scientific instruments like microscope, telescopes. So wherever required it is used, right. So in this session we have come across very important concepts. One is regarding the real light rays and virtual light rays, which is very important, and then we came across the formation of image on a plane mirror. So and we have experimentally concluded that the images formed on a plane mirror are virtual images. 100% they are virtual images, they cannot be caught on the screen, right? And the next is the characteristics of the that is images formed on the plane mirror and the uses of plane mirrors. And another important property is lateral inversion. So this is very important. Please go with your textbook, read the textbook. So the sideways reversing of the object and the image of the object in the mirror is called as lateral inversion. This is the definition for lateral inversion. So I hope you enjoyed the entire session. So be with the textbook, read the textbook, understand the things, underline the important technical terms, try to pronounce it wherever that is required, write the spelling of it and practice that, because technical words are very useful in writing good answers. So practice the ray diagram which was done in today's session. So I hope you enjoyed the class. So stay home, stay safe, keep learning. Thank you.